In this video, I will show you how to find the capacitance of the DC link so you can get whatever ripple voltage you want. And this works with any type of converter. If you start modeling it with a voltage coming in and also a current coming in. So the first thing you want to do is to find the current going through the capacitor. So this will be equal to the capacitance multiplied by the change of voltage over the change of time. So, and the current going through the capacitor is also equal to I in minus I load. And we know that I load, so first I in, minus I load, and I load is the voltage in divided by the impedance of the load. So the change of voltage is equal to the ripple voltage that we want. Let's say that is X multiplied by V in. So we can set up this equation as C, and then we have X times V in over delta time is equal to I in minus V in over Z load. This would mean that the capacitance is equal to I in minus V in over Z load, and this over X times V in multiplied by delta time, right? So this is the exact capacitance that you want if you want the specific ripple current. But just to stay on the safe side, the capacitance should be larger or equal to this expression. So the delta in time, I didn't explain that, but that should be the maximum. So max of T rise and T fall. So let's do a quick example. So let's say that the duty cycle is 70%. This means that T on is equal to duty cycle multiplied by the period. And let's say that the period is 1 millisecond. So T equals 1 millisecond, right? Since the duty cycle is 70%, this means that T on is larger than T off. So then we choose to look at the position where delta T equals T on. Yeah, this means that, okay? So when T is on, there will go no current through the diode because this circuit here is short circuited because we closed that switch. So this means that I in equals 0. So when T is on, the change of voltage, so change of V in, would be negative. So V in is below 0. This will mean that X is also below 0, right? Let's say that we want the ripple voltage to be 4%. That would mean that the X would be minus 4%. Okay? So if we put all of these values into the equation for the capacitance, we will get that C is larger or equal to, then there's 0 minus V in over Z load divided by X multiplied by V in multiplied by delta T. So as you see here, we can cross over V in. It will cancel each other. So that leaves us with dt, which is delta t, it's the same, right? Over 4%, right? Multiplied by Z load. So if we say that Z load is equal to 1 ohm, let's just say that, we can now calculate the capacitance, which would be 70% multiplied by 1 millisecond over 4%. So the percent goes with the percent. And then multiply by 1. And this is capacitance, so it's farad. So this would be equal to 17.5 millifarad. Okay? So in order to get a ripple current, a ripple voltage of less than 4%, we need a capacitance which is larger than 17.5 millifarad.